All right? Any questions? It's clear? So this is basically the method of reduction of order method. So the method of reduction of order is reduction of order method Okay, so you have a homogeneous equation, right? For the reduction of order method, you have a homogeneous equation. This equation, the first solution is given. X1 is given. So the first solution is always given. What you need to do is to find the second solution, right? So what you do is to find the second solution. Right? So in order to find the second solution, what you do is to, instead of finding the second solution, you're going to find the fraction of the second solution and the first solution, right? Instead of x2, we need to find v, which is x2 over x1. Right? So instead of finding the second solution, what you do is you find the fraction x2 over x1. So in order to find the fraction x2 over x1, you need an equation. Equation for v by replacing x2 to be x1 times v. All right? So instead of solving for x2, what you do is you solve for v. So in order to solve for v, you need an equation for v. So what you do is that you replace x2 to be v times x1, and you plug it back into the equation, like here, right? Because x1 is given, the leftover is just an equation of v, like what you see here. V second e to the t is 0, right? Solve the equation for v by putting w is equal to v prime. So that the equation for w is first order, right? So when you put v to be x2 over x1, you're gonna replace in this equation for x2 x2 by v times x1, and then finally you're gonna get a second order equation for v, but you're gonna reduce the order by putting w to be v prime, and the equation for w will be a first order. So you know how to solve a first order equation. For first order equation, you use normally you use separation of variable. Any questions? It's clear, right? So basically, this is how you solve an homogeneous equation. To solve a non-homogeneous equation, you need to find a particular solution. So can I erase this? So solving inhomogeneous equation. So inhomogeneous equation. Right. So suppose that you have a x second plus b x prime plus c x is equal to f of t. All right. This is an inhomogeneous equation. But in this case, we still have constant coefficient, right? So in the previous class, we already know a method to solve it. The only thing that we don't know is how to find the particular solution. So the method right? So first, suppose that xp is a solution for the equation, right? So you're gonna have what? You have a x second. So you have a xp second plus b xp prime plus c xp is ft. Right? So in the previous class, we know how to solve already an inhomogeneous equation in which the special solution is given. So how do you solve an inhomogeneous equation given the special solution? Yes?
You subtract that equation we have for the particular solution from the original equation, and that will give you a homogeneous equation that you can use the heuristic method to solve.
Right. Can you sign at the back of the paper, please? So in this equation, the solution x is not known, but the particular solution is given, right? So what we do is the following. So you're gonna so x is not known, right? But xp is given. All right. So but we will solve. We will try to find y is equal to x minus xp, right? So you have xp second plus b xp prime plus ft. All right? So, I explain again. This is an inhomogeneous equation, right? So in the previous class, we know that, okay, we want to solve, if we want to solve this equation, and if I give you in advance a solution xp for this equation. So xp is already given. So x is not known, but xp is given. What you have to do is you try to find y, which is the difference between x and xp, right? So when you subtract the two equations, you're gonna get a x minus xp second plus b x minus xp prime plus c x minus xp is going to be 0, right? So a y second plus b y prime plus c y is equal to 0, right? It's clear? Now, how you solve this equation? Yes?
Find the roots.
Yes, can you hand the back of the paper, please? Right? Right, so we have to solve by the characteristic equation. So AR squared plus BR plus C is equal to 0. And then we have two solutions, x1 t and x2 t. So yt will be c1 x1 t plus c2 x2 t. All right? It's clear? I explain again. For an inhomogeneous equation, if I give you a special solution or a particular solution xp, so you have xp second plus bxp prime plus cxp is equal to ft, right? So in this case, x is the unknown, but xp is given. So if you know the xp, then you consider the difference x and xp. So when you consider the difference x and xp, you have ax minus xp second plus bx minus xp plus cx minus xp is 0. So the difference between x and xp is the solution of the homogeneous equation, right? So because this is a homogeneous equation, you can solve it by the method of characteristic. So you want to consider AR squared plus BI plus C. You use the previous method. You find two solutions, x1 and x2. So the difference will be C1 times x1 plus C2 times x2. So how can you find the solution x? Yes?
Because y is equal to x minus xp, then the solution will be x equals xp plus your solution for
Yes.
y.
Can you stand the binder, please? So because y is the difference between x and xp, right? So you're gonna have x minus xpt is c1 x1t plus c2 x2t, right? So xt will be xpt plus c1 x1t plus c2 x2t. All right? Questions? So basically, this is why in the homework they asked you to solve the inhomogeneous equation, but they gave you already the particular solution. Basically, what you do is to solve the homogeneous equation, right? So in the previous class, we know this method, but we don't know how to find this special or particular solution. So the goal of this class is to find the particular solution, right? So I explain again. If I give you a inhomogeneous equation, what you do is that first you have to find a particular solution. If you know one solution, then you know how to solve the equation, because with this particular solution, you consider the difference between the solution and the particular solution. This difference will be the solution of the homogeneous equation, right? And you know how to solve the homogeneous equation because you know the method of characteristic. Basically, the difference between x and xp will be c1 x1, which is one solution of this guy, and c2 x2, which is another solution of this guy. Now, the solution of the inhomogeneous equation will be the sum of the particular solution and the solution of the homogeneous equation, right? So this is particular solution. Solutions. And this is solution of the homogeneous equation. Right? So basically, the solution of the inhomogeneous equation will be the sum of a particular solution and the solution of the homogeneous equation. Right? So this is solution of the inhomogeneous equation. Right? It's clear? Now, the goal of this class is to find a particular solution. So the goal of this class is to find a particular solution. Can you put the homework here, please? So the goal of this class is to find the particular solution, because if you know the particular solution, you're gonna Alright, so to solve an inhomogeneous equation, if you know one solution, you know all of the solutions. Why? Because if you know one solution, if you know this particular solution, then the other solution will be adding this particular solution and the solution of the homogeneous equation. So in the previous class, the particular solution was given, and we didn't know how to find this particular solution. But in this class, we're going to solve this particular solution, and the method is the method of undetermined coefficient. Undetermined coefficients. All right. So, so the method to find a particular solution of the inhomogeneous equation is the method of undetermined coefficients. So basically, how many methods that we've learned so far? The very first method is, yes?
Separation of variables.
Can you stand the back of the paper, please? So separation of variables. So what is the range of application for the separation of variable? For which kind of equation you can use separation of variable? Yes?
Linear first order homogeneous.
Yes. Can you sign the back of the paper, please? So this is linear first order, and not necessarily homogeneous, because you can have x prime is equal to t, right? So linear first order. The second method is, yes? Can you sign back the paper, please? The second one is integrated factor. So this method is for what? Yes? Of what? Which order? Yes, can you sign the back of the paper, please? So this is still linear at first order, right? And the next method is what? Yes? And the range of application?
That's for second order homogeneous.
Constant coefficient. Can you sign the back of the paper, please? So the next one is characteristic equation. So this is linear, second order, homogeneous, constant coefficient. And the next method is what? Yes?
The reduction order method.
And the range of application is?
Second order non-constant homogeneous equations.
Yes, can you sign the back of the paper, please? So you have reduction of order. So this is linear, second order, homogeneous, non-constant coefficient. X1 is given, right? All right, so for the reduction of order method, this is applicable for both constant and non-constant coefficient equation, but the crucial thing is that you have to know one solution. And this is for homogeneous, right? So now the method of undetermined coefficient will be used to solve inhomogeneous equation. Basically, to solve inhomogeneous equation, you add a particular solution and a solution of the homogeneous equation. So the method of undetermined coefficient will be used to find a particular solution. It's clear, right? Any questions on this so far? So so now you have method of undetermined coefficient. Case number 1. You have ax second plus bx prime plus cx is equal to ft, where ft is a0 plus a1 t plus am t to the m. So the particular solution has the form xp is t to the k, a0 plus a1t plus am t to the m, and k is the multiplicity of r is equal to 0 as the root of a r square plus br plus c is equal to 0, right? I'm gonna explain the multiplicity in a second. Right. So in the method of undetermined coefficient, this is the most complicated thing in this class, I think. So you're gonna have what? A x second plus bx prime plus cx is equal to ft. So ABC, they're all constant, which means that if you know one particular solution, you're gonna know the solution of the homogeneous equation because the coefficients are constant, right? So the key part now is to find this particular solution. So how do you find this particular solution? There are several cases. There are 9 cases in the book, and this is the simplest case. F is a polynomial of order m, right? So this is polynomial of order m So this is basically a polynomial of order m. So a0, a1, am, that coefficient of 1 t to the m. This is the form of the forcings f. The particular solution has the form exactly like this. So you have a form, and what you have to find is all of the constant. So the first part is this polynomial. This polynomial has the same order with this polynomial, right? So this is a polynomial of order m. So in the particular solution, you have to have a polynomial of order n. You don't know the coefficients, and this is what you have to find, right? I'm gonna explain to you once in 1 second how do you find all of those constants. And the next term is this t to the k. The k here is the multiplicity of r to be 0 as a root of a b squared plus br plus c is 0. So this is the characteristic equation of this equation. So what is the multiplicity? The multiplicity is the time that r appears in this polynomial as a root, right? So for instance, so if c is 0 and a, b are different, so consider a polynomial a squared plus br plus c is 0 if we can factor AR square plus BR plus C to be A times R1 R minus R2. Now, if I consider this characteristic equation, and I can write this characteristic equation as a product of A times R minus R1 R minus R2, what can I say about R1 and R2? Yes?
That R1 and R2 are solutions for the polynomial
Yes.
A squared plus B over C equals 0.
Can you say at the back of the paper, please? So if you can write this of this form, which means that A R minus R1 R minus R2 is 0. So definition of multiplicity. Multiplicity. So if you can write this quadratic form as A times R minus 1 R minus 2, so this equation, the equation A R minus R1 R minus R2 is equal to 0 has two solutions, right? R1 and R2. It's clear? Now, what happens if R1 is equal to R2? In this case, you have two solutions or two roots, right? So what happens with R1 if R1 is equal to R2? So what do I call R1 if R1 is equal to R2? Yes?
A double root?
Yes, it's a double root. So if R1 is equal to R2, R1 is a double root, right? So why do I call it a double root? Yes?
Because you can rewrite it as like A R minus R1 squared.
Yes. Can you sign the back of the paper, please? Because in this case, AR square plus BR plus C is A R minus R1 square is equal to 0, right? So this is the double. Right? So this is a double root because you have two roots that are identically the same. So in this case, we say that R1 has the multiplicity as a solution of AR square plus BR plus C is 0, right? So I said that, okay, because this is a double root, the multiplicity of R1 is 2, right? So, so this is case number 1. Case number 2, if R1 is different from R2. If R1 is different from R2, can you guess what is the multiplicity of R1 and R2? Yes? Yes, can you say the back of the paper, please? If R1 is different from R2, we say that the multiplicity of R1 is 1 and the multiplicity is 1 and the multiplicity of R2 is also 1, right? So I explain again. So if I consider this second order polynomial or quadratic form, AR squared plus BR plus C is 0, if I can write AR squared plus BR plus C to be A R minus R1 R minus R2, then the equation A R minus R1 R minus R2 is 0, has two roots, R1 and R2, right? So in the case that R1 is equal to R2, this becomes a double root, and the multiplicity of this root is 2. Now if they are both different, you have two solutions, and the two solutions are different, but the multiplicity of each of them is 1. Now, third case, if I consider a number R3, and R3 is different from R1 and R2, what is the multiplicity of R3?
Also 1.
R3 is a number which is completely different from R1 and R2, right? So what is the multiplicity of R3 as a solution of this equation? Is it a solution of this equation? No. 0. Right. Can you say at the back of the paper, please? So since R3 is not a solution, the multiplicity of R3 is 0. Right? It's clear? So if it's not a solution, then the multiplicity of this number is 0. Because you don't see it in the equation, right? So if those if the two solutions are different, the multiplicity is 1 because each of them appear 1 in this polynomial, right? And if this is if they are both equal, so the multiplicity is 2 because it appears twice in the equation. Questions? Right. So basically, this is the definition of multiplicity. So this number k is the multiplicity of 0 as a solution of this equation. So you have to look into so if 0 is not a solution of this equation, this k will be 0. Right? So let's consider one example. Example. You have r squared plus r is equal to 0. Multiplicity of 0 and multiplicity of 2. Right? So now, I have an equation, r squared plus r is equal to 0, and I want to consider the multiplicity of 0 as a solution of this equation. So what is the multiplicity of 0 of this equation as a solution of this equation? Yes? Why? Yes, can you say at the back of the paper, please? So here you have what? You have r squared plus r is r plus 1. And so this is the equation has two solutions, right? 0 and minus 1. So 0 has multiplicity 1. Right? So because this equation can be factorized like r plus 1 is 0, so you have two solutions, 0 and minus 1. So basically 0 has multiplicity 1. So what is the multiplicity of 2? Yes?
2 isn't a solution, so you have a multiplicity of 0.
Yes, can you sign the back of the paper, please? So 2 is not a solution. Right, so then the multiplicity is is 0, right? So 2 is not a solution, so multiplicity has to be 0. It's clear? So this is how you determine this case. All right, so this is the general method. Let us try to go to one example so that you understand how to find a particular solution. Any questions on this? Now, so this is example 2.6.1. So you have x second plus minus 3x prime plus 2x is 2t squared plus 1. So to solve this equation, what should we do? What is the general strategy? Yes?
First, we want to find a particular solution so we can write that equation as a homogeneous equation, and then
Yes.
use the characteristic method to solve it.
Yes, can you just hand it back to the paper, please? So you're gonna solve it by two steps. First, you have to find a homogeneous, find a particular solution. And second, solve the homogeneous equation. All right? So to solve this equation, what you do is first you have to find a particular solution. After you have a particular solution, you take the difference between the two equations, then you get a homogeneous equation. Then you solve the homogeneous equation using the characteristic equation, right? So let us do step number 1. So step number 1, what is the ft in this formula, in that special case? Yes?
ft is 2t squared plus 1.
Yes, can you just add the back of the paper, please? So ft will be 2t squared plus 1. Now I want to know what is the m and a0 to am. a0, am. Right, so in this formula that I have here, I want to know m, and I want to know a0, a1, a2, am. Yes?
Is it 2?
M is 2, right? Can you just hand the back of the paper, please? So m will be the order of the polynomial, right? So now I want to know what is a0, a1, a2. Yes?
So A0 is 1, A1 is 0, and then A2 is 2.
Yes, can you just hand it back to the paper, please? So a0 is 1, a1 is 0, and a2 is 2. Right, so basically you have f is a0 plus a1t plus a2t squared. And this is 1 plus 0t plus 2t squared. Right? It's clear? Right, so I explain again. I'm going to use this formula here. In this case, f is a polynomial. So m is the degree of this polynomial. So f is 2t squared plus 1. So m is 2. Now I want to identify 0, a1, a2. So because f is 1 plus 0t plus 2c squared, so a0 is 1, a1 is 0, and a2 is 2. Right. So what is the form of XP? So the particular solution has a given explicit form. In this case, what is the form?
Well, it's the form provided there, the t to the k times a0 plus a1t plus am times t to the m, but we don't know the
Yes.
coefficients yet.
Yes, can you stand the back of the paper, please? So XP has to have the form. So XPT is t to the k, a0, a1t plus a2t squared. All right. In this case, you know already m. M is 2, so you know that okay, this polynomial is not going to any big M. It has to be of the form t to the k, a0 plus a1 t plus a2 t squared, right? Because m is 2 already. M is already 2. Right. So now the next step is to determine K. So to determine K, I have to write out the characteristic equation, right? A squared plus BR plus C 0, right? The equation. So what is the characteristic equation in this case? Yes?
R squared minus 3R plus 2.
Can you say at the back of the page, please? So you have R squared minus 3R plus 2 is 0, right? Now K here is the multiplicity of 0 as a solution of this equation, right? K is the multiplicity of 0. So what is the multiplicity of 0 as a solution of this equation? Yes?
0 because it's not a solution.
Right, can you say at the back of the paper, please? So 0 is not a solution. Of R squared minus 3R plus 2 is 0, since 0 squared minus 3 is 0 plus 2 is 2, different from 0, right? So K is 0, right? So because this is x second minus 3x prime plus 2x, so the characteristic equation is R squared minus 3R plus 2 is 0, right? Now I have to look for the multiplicity of 0. So of course 0 is not a solution of this guy, because you replace 0 here, you get 0 squared minus 3 times 0 plus 2. This is equal to 0, and this is equal to 2, and 2 is different from 0. So the multiplicity K has to be 0, right? So which means that what is the form of XP in this case? Yes?
Or 1 plus 2t squared, or a0 plus a1t plus a2.
Yes. Can you say at the back of the paper, please? So I can replace 0 here, right? So it's going to be xp of t is t to the 0 times a0 plus a1 t plus a2 t squared. And this is a0 plus a1 t plus a2 t squared. Because t to power 0 is 1, right? Now I explain again from the beginning. I'm going to use this formula here. You're going to have 9 of that, and this is a lot. But in the next class, I'm going to print for you the formula, and this formula you can use in that exam. So don't worry. So now you have what? You have f is 2t squared plus 1, right? So in this case, m is 2 because the order of this polynomial is 2. So f has the form a0 plus a1t plus a2t squared. So which means that a0 is 1, a1 is 0, a2 is 2. Right? So now you use that formula. So xp has to have the form t to the k, a0 plus a1t plus a2t squared. Right? You want to determine c. So k is the multiplicity of 0 as the solution of the characteristic equation. So the first thing you have to do is to write out a characteristic equation. This is x second minus 3x prime plus 2x. So the characteristic equation is 2r squared minus 3r plus 2. You replace 0. 0 is not a solution. So the multiplicity of 0 is 0, which means that you have to replace k to be 0. So here you have t to power 0, which means that finally you get a0 plus a1t plus a2t squared. Questions? Now your job now is to determine a0, a1, a2t squared. Right? Yes?
Is k always the multiplicity of 0?
It's always. Right? So it's always the multiplicity of 0. Now you have to determine this this a. So xp, then xp has to have the form a0 plus a1t plus a2t squared. And this is why we call it the method of undetermined coefficient. So the undetermined coefficient are a0, a1, and a2. Right? So this is why we call the method of undetermined coefficients. So the undetermined coefficients are a0, a1, and a2. So how do I find a0, a1, and a2? Yes?
What if we took the second and first derivatives of that expression that we found for xp and put it back into
Right.
the original differential equation?
Yes. Can you sign the back of the paper, please? So you know that this is a solution of this equation. So what you do now is to put this form back into the equation, right? So you have what? You have xp second minus 3xp prime plus 2xp is equal to 2x squared plus 1, right? So you know that xp is a particular solution, which means that xp second minus 3xp prime plus 2xp is equal to 2x squared plus 1, right? This is one solution. What you do now is you have to plug this form back into the equation, and you determine the coefficients, right? So now what is xp second? Or xp prime? What is xp prime? Yes?
It's a1 plus 2 times a2 times t.
Yes, can you sign the back of the paper, please? So xp prime will be a1 plus 2 times a2t. Right, now what is xp? So minus 3xp prime will give me minus 3a1 minus 6a2t, right? So xp second. Yes?
2at.
Yes, can you sign the back of the paper, please? 2a2. Right. Can you sign the back of the paper, please? Yes. So now right, so what you do is, you know that xp is the solution of this equation. So xp second minus 3xp prime plus xp has to be 2t squared plus 1. Right? So xp prime is the derivative of this guy, so it's a1 plus 2a2t, and minus 3xp prime will be minus 3a1 minus 6a2t, and xp second will be 2. It's clear? Now I have to put everything back into this equation. So I'm gonna have 2a2, right, plus minus 3a1 minus 6a2t plus 2a0 plus a1t plus a2t squared, and this is equal to 2t squared plus 1. Right, so this is xp prime second. This is minus 3xp prime, and this is 2xp. Right? What I do is from this equation, I have xp second minus 3xp prime plus 2xp is equal to 2t squared plus 1. What I do now is I take the first derivative. So the first derivative gives me a1 plus 2a2t. So minus 3xp prime will be minus 3a1 minus 6a2t, and xp second is a2, right? Let's just take the derivative of this guy. So I replace everything. So xp second I'm gonna replace by 2a2, minus 3xp prime will be minus 3a1 minus 6a2t, and 2xp will be 2a0 plus a1t plus a2t squared, and everything will be 2t squared plus 1. All right? Any questions? questions? So, the next step, what should I do? Yes?
I wasn't raising my hand, but do we have to move to step 2 to solve the homogeneous equation?
Not yet, not yet. You have to find A0, A1, A2 first. So how do I find A0, A2, A1? Yes?
You could group them by the t terms, like the powers of t terms. So like all the c terms with the
Right.
t squared powers grow together. All the one of the single power of t go together, and then the t0 powers can group together.
Right. Can you stand back up, please? We're gonna group all of the guy with the same order together, and we're gonna identify the coefficient, right? So the first order will be this one and this one. So I have 2A2 minus 3A1 plus 2A0. Right? So I'm going to group all of the guys with the same order. And the second one will be minus A2 and this guy. Right? So I'm going to get plus minus A2, 6A2 plus 2A1T. Alright? And the last term will be this guy. And I have 2A2T squared. And finally I have 2T squared plus 1. Alright? Expand again. So here, after I replace all of the derivative inside the equation for xp, this is the equation that I get. Now I'm going to group all of the terms of the same order. So 2A2 minus 3A1 plus 2A0. This is the term without any t. The next term will be minus 6A2 plus 2A1. This is for t. And the last term will be 2A1, t squared. Everything will become 2t squared plus 1. Right? Questions? The next step will be? Yes?
Factor out the t's from the equation.
No. Yes?
Since you kind of group them together by the powers of t, you can make 3 new equations equaling to the ace of 0, ace of 1, ace of 2, like based off the other side.
Yes, can you stand back up to the paper, please? So now you're going to identify the coefficient. The coefficient. Right? So you're going to identify the coefficient to get 3 new equations. So the first thing, you have to identify 2A2 with 2, right? So you're going to have 2A2 is equal to 2. All right? Because the coefficient of t squared has to be equal to the coefficient of t squared. So 2A2 has to be equal to 2. Now, I'm going to need to identify the coefficient of t. So I have minus 6A2 plus 2A1 is equal to, yes?
0.
Yes, can you say at the back of the paper, please? Right? So the next term is, because on the left-hand side, right-hand side you don't have t, and on the right-hand side you have t. So minus 6A2 plus 2A1 has to be 0. So the last term will be 2A2 minus 3A1 plus 2A0 is equal to, yes?
1.
Yes, can you say at the back of the paper, please? All right? So after you put all of the coefficient here into the equation, you have what? You have 2A2 is 2 minus 6A2 plus 2A1 is 0 because this is the coefficient of t, and the last one is 2A2 minus 3A1 plus 2A2 is 1 because this is the coefficient of the last. Yes?
How do you know, so the coefficient of the t term is 0?
The t term is 0 because here you don't have t, which means that here you have 0t, right? So which means that you have to identify this with 0. Right, so the coefficient of the t is 0 because on the right hand side you don't have t, so which means that here you can put a 0t, meaning that this guy is 0. And the last one is that, okay, this one has to be 1. Alright, now I have to solve this equation to find a with 0, a1, a2. So, how can I solve this equation? Yes?
Yeah, so first you just start with 2a2 equals 2.
Yes.
Just divide both sides by 2, you get a2 equals 1.
Yes, here's hand back the paper, please. Alright, so now because 2a2 is 2, then a2 is 1. And the next step, yes?
You can find a1 is equal to 3 by plugging a2 is equal to 1 into negative 6 a2 plus 2a1.
Here's hand back the paper, please. So you have what? You have minus 6a2 plus 2a1 is 0, which means that minus 6 plus 2a1 is 0. So a1 is 3. The last equation,
You can do the same thing, just plug in a2 and a1 into the equation and solving for a0.
yes, can you stand back the paper, please? So you have 2a2 minus 3a1 plus 2a0 is 1, which means that 2 minus 3 times 3 plus 2a0 is 1. So this is 2 minus 9 plus 2a0 is 1. So which means that minus 7 plus 2a0 is 1. So 2a0 is 8. So a0 is 4. Right? So I explain again. The first equation, 2a2 is 2, gives you a2 is 1. Right? Now, the second equation is minus 6a2 plus 2a1 is 0. You replace a2 by 1 here, you have minus 6 plus 2a1 is 0, which means that a1 is 3. In the last equation, you have 2a2 minus 3a1 plus 2a2 is a0 is 1. So a2 is 1, a1 is 3, so you have 2 minus 3 times 3 plus 2a0 is 1. This is 2 minus 9 plus 2a0 is 1. So 2 minus 9 is minus 7. So minus 7 plus 2a0 is 1. I put minus 7 here, so 2a0 is 8, so a0 is 4. Right? Now xp will be a0 plus a1t plus a2t squared. And this is plus 3t plus t squared. Right, this is the particular solution. All right, it's clear. This is a lot of work, right? Then you have to do the second step, and you're gonna take a sum. This is so in the test you are allowed to take the table, right? So in the test, this formula is given. The formula that I wrote in the beginning, xp is equal to t to the k, is a given. I'm gonna print it out. I'm gonna give it to you on Tuesday. Right? So this is a particular solution. So step number 2. So what is step number 2? Yes?
Is now when you start to solve for the homogeneous equation by subtracting xp from the original equation.
Yes, can you sign the back of the paper, please? So x will be xp plus solution of the homogeneous equation plus y. Y is the solution of the homogeneous equation. Right? So what you do is you take the sum of xp and the solution of the homogeneous equation, in which the solution of the homogeneous equation will be minus 3y prime plus 2y is equal to 0. Right? So after you find the particular solution, what you have to do now is to solve the homogeneous equation, which is simpler. So this is why in homework they gave you already the particular solution. They asked you to solve the homogeneous equation. But now the hard part will be to find this particular solution. And you have to solve this big system. So how can I solve this homogeneous equation? Yes?
Subtract the xp from y.
Yes, I subtract already, right? So I have x is the solution, x is the particular solution plus y is the solution of homogeneous equation. So how do I solve this equation? This is homogeneous, so how do I solve it? Yes? Yes, can you sign the back of the paper, please? So you solve the homogeneous equation by using the characteristic equation method. Right, so you write out the r squared minus 3r plus 2 is 0. What are the two roots of this equation? Yes?
R equals 1 and
1 and
2. 2.
yes, can you sign the back of the paper, please? So this you can factorize now. So r minus 1 and r minus 2 is 0, right? Why? Because remember that you're gonna, how do you find the two roots here? Remember the shortcut that I told you last time? How do I find 1 and 2 quickly without doing the delta? Yes?
And you can just factor it, so you know r equals 1,
So how do you know that this is 1 and 2?
because the equation equals 0. You can just look at it, but you could also use the formula that is given for r1 and r2.
Yes, but I don't want to use that formula. There's a quick way to do that. Yes?
They add the negative b and multiply c. Like
Yes.
R1.
Can you sign the back of the paper, please? So you're gonna find. So the quick method. The quick trick is to find r1 plus r2 to be 3, which is minus r minus 3. This is 3, and r1 times r2 is equal to 2. Right? So the quick way is, without doing the delta is that you're gonna find two numbers whose sum is 3, which is minus of this coefficient, and the product will be 2, right? So the two numbers that you see right away is 1 and 2, right? So then you put it here, r minus r1, r minus r2 is 0. It's clear? So this is the quick way. You don't have to do the delta business. It's faster. Right. So now because now you have r1 is 1 and r2 is 2. What is x1 and x2? Yes.
x1 is e to t, and x2 is e to t.
Yes. Can you say at the back of the paper, please? So now you have x1 t is e to the t, and x2t will be e to the 2t. Right? It's clear? What is the general form of y? Yes?
C1 times e to the t plus c2 times e to the 2t.
Can you sign the back of the paper, please? So you're going to have y is c1 e to the t plus c2 e to the 2t. Questions? It's clear? So this is the easier part. So I explain again. After you found the particular solution, the solution of the equation will be the sum of this particular solution and the solution of the homogeneous equation, right? Now what you have to do is to solve for the homogeneous equation. Y second minus 3y prime plus 2 is equal to 0. The characteristic equation of this guy is r squared minus 3r plus 2 is 0. To solve this equation, the quick trick is that you find two numbers, r1 and r2, such that r1 plus r2 is 3 and r1 times r2 is 2. So they are 1 and 2. You know that this equation has two roots, 1 and 2. So x1 is e to the t and x2 is e to the 2t. Right? So yt will be c1 e to the t plus c2 e to the 2t. and this is the form y. So what is the form of the solution of the inhomogeneous equation? Yes?
X equals xp, like, so it'd be like 4 plus 3t plus t squared equals c1 e to t plus c2 e to t.
Can you sign the back of the paper, please? So now the solution will be xp plus yt, right? So xp is 4 plus 3t plus 2 plus t squared plus c1 e to the t plus c2 e to the 2t. It's clear? Questions? Right? So basically this is, the first part will be a lot of work, but you have to do it. Any questions? It's clear? We're gonna go to another example, and any questions on this? Okay, so let us go to the next example. X second minus 3x prime is 2t squared. All right, so xp, so what is ft in this case? Yes?
2t squared plus 1.
Yes, can you sign the back of the paper, please? 2t squared plus 1. So what is m? Yes?
2.
Yes. Can you sign the back of the paper, please? So in this case, m is 2. So what is the form of xp? Yes?
It's t to the k times a0 plus a1 a2 t squared.
Yes, can you sign the back of the paper, please? So it's going to be t to the k, a0 plus a1, t plus a2, t squared, right? So this polynomial has to be of the same order with the polynomial of ft, right? So the number 2 here has to be equal to the number 2 here. So if ft is of second order, then inside of this guy, you're going to have something of second order, and you have t to the k. So now you have x second minus 3x prime. What is the characteristic? Polynomial. Yes?
R squared minus 3, right?
Yes. Yes, can you sign the back of the paper, please? R squared minus 3i is 0. What is the multiplicity? What is the multiplicity of 0? Yes? 1. Yes. Can you sign the back of the paper, please? So because r squared minus 3r is 0, and this is r minus 3, so it has two solutions. 0 and 3. So the multiplicity of 0 is 1. Right? It's clear? So I explain again. So in this form, f is 2t squared plus 2. The order of f is 2. This is why here you have a0 plus a1t plus a2t squared, and you have to multiply with t to the k. Now I have to identify this k. I write out the characteristic equation, which is r squared minus 3i is 0. So r squared minus 3i is r minus 3. So you have two solutions, 0 and 3. 0 is one solution, and this is the single solution. It's not a double solution. So the multiplicity is 1. Now what is the form of xp? Yes?
Since k equals 1, it's going to be xp equals t times a0 plus a1t plus a2t squared.
Yes. Can you sign the back of the paper, please? So xp will be t times a0 plus a1t plus a2t squared, and this is a0t plus a1t squared plus a2t to power 3. All right? Questions? I explain again. So in this case, you have an inhomogeneous equation. X second minus 3x prime is 2t squared plus 1. The force will be 2t squared plus 1. In this expression, the polynomial has degree 2. This is why xp has to have t to the k, a0 plus a1t and a2t squared. So you stop at 2 because m is 2. The characteristic is r squared minus 3i0. So when you factorize, the form 0 is a solution. So the multiplicity of 0 is 1. So xp will be t times a0 plus a1t plus a2t squared. And this is, you multiply t inside the equation, you get this one. So what is the next step? Yes?
Take the derivative of xp.
Yes. You're going to replace the first and the second derivative of xp into this equation, right? Can you sign the back calculator, please? So you have xp second minus 3xp prime is equal to 2t squared plus 1. Right. So what is xp prime?
A0 plus, or yeah, A0 plus 2, A1t plus 3, or A2t squared.
Can you sign the back paper, please? So it's going to give you a0 plus 2a1t plus 3a2t squared. Right, so now xp second. What is xp second? Yes?
2a1 plus 6a2t.
Yes, can you sign at the back paper, please? So you have 2a1 plus 6a2t. All right? Questions? So the next step is to replace this into the equation, right? We're going to continue that on Tuesday. Have a nice weekend.